Hey there, math fans. Continuing our little tour of some of these 3D projects. I came across, as I was thinking about 3D shapes, I thought of what questions have students asked me a lot over my 20 years of teaching, and one was, how do we rotate around a slant axis? A few times I've sat down with students. I looked online and various people have done some work on this, so this is not original, but I thought, well, let's explore and see what happens. So I made a little project where I ask a few questions. There is a formula. Now, I think there are some flaws in this formula. This is a formula I did find something online that got me going to get this, so this is not original with me, and I found it in more than one place. But I know there are some problems with it. So that would be an interesting piece of this. Like, when does the formula work? When does it not work? But I strongly believe that when you're given a new formula, you should test it out. So this is more of a project. Like, test it out, make sure that for a circle it gives the right answer. And then play around with some other things. And then I ask a few questions, like, what would you have the axis be? And then I also, so if anybody solves these problems, I'm willing to share what I've made here. So here's an example of this volume of revolution rotated around the x-axis. So there we go. No big whoop. But I spent some time to try to come up with a general animation. And so I made it so I could move the line. Ooh la la. I was quite pleased with myself. So what we're doing here is we're making two perpendiculars. And the numbers are based off of where it hits the curve. In this case, it's x squared. But I was able to generate this thing, which I think then, and there's other ways to solve this problem. You could rotate, there's all sorts of things, but I found it interesting that we could make this. I would be cool to sort of ask various questions. The question I asked is, what slope would you want? Or I asked a couple questions, but what slope will make that area smallest? And it might be a place where it like crosses through. So that's kind of interesting. So anyways, if that interests you, let me know what your questions would be. But I do think, like I said, it would be interesting to see some of the flaws, because there are flaws. Like, what if, what if the curve changes onto one of the verticals? But I made it so that we can just play around with it, which is how I would encourage students to do it. So I'm going to have students answer the question of, what if we know exactly, given a certain slope, given a certain value here for these two numbers, I make the students figure out that's got to be half the volume of a sphere. So check the formula, see if it works. That's always a good first step when you're doing something like this. Okay. But what I love about it is I've made it so we can be very creative. Pick any function you want. Here's a cubic. I would really love to print some of these things, and I don't think it would be hard. But what's cool is we can find the volume of that thing. I think that's pretty slick. Okay, so think up what your questions are. Check out that project if that interests you. See if you can answer those questions and see if you can come up with your own.